Vectors in R2 and R3. Consider the vectors shown below. Write the vectors in Cartesian form. Find sum of the given vectors. We are given two vectors here. Vector A starts from the origin. It is called position vector. And vector B has a tail at a coordinate point of -4 and 5 and head at -2 and 3. So that is called a free vector. So vectors are actually free, they can be anywhere in the space. But when we specifically fix their position so that the tail ends up at the origin, then it is called a position vector. Now let's find out what is the representation of vector A in Cartesian form. So vector A can be written with the help of its coordinate points. So if we place the tail at the origin, then difference between x position and y position will be same as x and y coordinate points, right? So x coordinate point is 4 and for y it is 6. So the vector A can be represented as 4, 6 in Cartesian form. Now for vector B, what do? For vector B, we find the points of tail and head and then take the difference. Let us say that the tail is at point A and head is at point B. In that case, what are the coordinates of point A and B? That they are necessary to be determined. A is the point -4, 5 and B is -2, 3. So the vector B will be difference in x values, B minus A, right? So vector B basically is A to B, right? Which we can find by finding difference in x values and difference in y values. So it can be written as -2 minus of -4. So that gives you the x coordinate, and for y it is 3 minus 5. These are called the coordinates of vector B. And now you can write this as equal to -2 plus 4 is 2 and 3 minus 5 is -2. So that is how you can specify vector B. Now part B of the question is find sum of given vectors. So when we know the coordinate points of a vector, then it's very simple. We say vector A plus vector B is equal to x1, x2, add them, and y's, add them. You get your answer. You get 4 plus 2. That is the sum of x values. And for the y values, it is 6 plus -2, right? That gives you the answer, which is 4 plus 2 is 6, and 6 minus 2 is 4. So we get sum of the two vectors as vector 6 and 4, right? You can do algebraic method of adding vectors by placing the other vector, let's say AB, with tail on the head of the first vector. So you get 2 units right, 2 down. So you get 1 and 2 out of the scale anyway, 2 down right there. So that becomes the sum of the vectors, right? We are just checking the answer. So this vector will become A plus B. So what are the coordinates of this? So this is 5, that will be 6, right? And this is 4, so it is checked, right? So that is so simple as that. And therefore we say vector algebra can be done very easily if you write down vectors in Cartesian forms. So that is a huge advantage of representing vectors in this particular form. I hope you appreciate it. Thank you.